Okay, I think we are live. Good evening, everyone. Welcome to a pleasant early spring, late winter, Eastern Mojave Desert evening. My name is Mike Jerry, and going to be doing some astronomy tonight. So, got the narrowband filter in and the IDAS NBZ, so it's going to be lots of nebulas tonight, which are always pretty to see, with a little bit of moon in the sky. Hopefully we'll try and avoid that as much as we can and not get too many light gradients and weird things going on. Yeah, it should be some cool stuff. So, first thing I want to do here is let's turn that off and show you my setup. Why is this not opening? Okay, so this is my telescope. It's an 8-inch Schmidt-Cassegrain telescope riding on an AM5 strain wave mount. Camera's stuck in up here with the Hyperstar, and it's giving me the pictures. And I'm sitting at a table back here. And it all, of course, is riding on my spare no expense cinder block pier, which stays outside, and everything else goes inside when the astronomy is done. But that is what I'm using tonight. So let's take a look at, let's open up our observation list of emission nebula. And I think what I wanted to start with tonight was Flaming Star, which is right next to where we are now. The moon is not far away from us. I'm not seeing it right now. Is it further out? Okay, yeah, it's right here. So, you know, it's kind of close by, but I think we'll still be able to see the Flaming Star anyway pretty well. Let's see, let's go down to that one. Even a little lower to that one. Yeah, let's go to there. That should work. No, not that one, not that one. All right. And we'll plate solve on that. Hey, Mike. Good to see you. All right, and that looks like it's now on. So let's start the imaging. Let our little script run here. I think we'll be far enough off the moon to not get a bunch of gradients and stuff on it, hopefully. And we need you to be out of the way so our picture is bigger. Okay, and then I need to have you there. And where is my SharpCap? There's that. Okay. Oh, do we have a... No, we don't really have Flaming Star Nebula. Caldwell 31. Let's see if we can figure out... It's probably another star-forming region. But... I see 405. Okay. Let's zoom in on that. Adjust this a little bit here. Make it pop a bit more. Yeah, there we go. Seems like we're still seeing, well... Oh, I forgot to put on my flat, which is why it's so bright in the middle. Flats eliminate uneven illumination. So not, all optics collect light unevenly, ununiformly. So the flats take care of that and make it. And there we go. That's better. Of course, it changes everything. Doink. Here and here. And we'll back off the stretch a little bit for the first couple of, and also need to drop the blue out a little bit too. Okay. Good evening, everyone. Mike, Michael, and Mystic. Thanks for stopping by. I was wondering how many folks I would have showing up tonight, given that I only announced this a couple hours ago, so actually only about 90 minutes ago. So good to see you guys are here. Are you using a filter tonight? Yes, tonight I'm using an IDAS NBZ, the original NBZ filter. Not the high speed, just the regular one. Because the high speed one, the regular one works just great even at f/19. So all right, anyway, IC405, also called Flaming Star, emission and reflection nebula in Auriga. Celestial coordinates is located near the emission nebula IC410. The nebula measures approximately, it was 1,500 light years away from Earth. Believe that the proper motion of the central star can be traced back to the Orion's belt area. So possibly another thing formed in the huge stellar nursery that Orion is. Yeah, I agree, Michael. The NBZ, I think, is my favorite filter of all time. It works really, the original NBZ just works really well at all speeds, at all optical speeds, and somehow it is more than, it adds up to be more than its parts. It's 1 + 1 = 3 kind of deal. It just works really well. It's a 12 nanometer bandwidth filter for O3 and hydrogen alpha, or hydrogen, and but still it doesn't let in too much other stuff, but it seems to behave about as well as more restrictive filters, and yet it works really well, even faster than F2. So I really like it. It's been a very good filter for me, in fact. And then they went ahead and changed it. Now they don't even make it anymore. It's now the NBZ2, which is in my opinion, significantly worse filter. They've really narrowed. What the heck did they really narrowed one of the bands. I think they narrowed the oxygen even further. So it's only like 7 or 8 for the oxygen, and I don't know. Anyway, they changed it around, and and so that now it's called the NBZ2. So they don't even make this filter anymore, and I thought they hit it out of the park with this filter. So because they don't make it anymore, I actually saw a good deal on the Cloudy Nights Classifieds a few weeks back, and somebody's selling another one. I bought a second one, so just to have a backup. So because they're going to get more and more rare since they don't make them anymore. But anyway, is it a Wolf-Rayet? It's AE Aurigae a runaway star. It lights the flaming star nebula. Let's see if it has its own. It's an O-type main sequence. No, so it's an O-type main sequence. I don't think it's a Wolf-Rayet. It lights up the flaming star, but it wasn't formed within the flaming star. Instead, it's passing through the nebula at high speed and producing a violent bow shock and high-energy electromagnetic radiation. So it's like whizzing through the area. Huh. Information on that star. Thanks for making me look that up, Michael. Although information about that star is actually more interesting than the flaming star itself. So, yeah, this guy, they think, was formed around the area of somewhere around Orion, somewhere in probably the Great Orion Nebula, and it's just zipping through this area right now and lighting up this whole area of nebulosity. You start to see there's some lighter color in this now, as it's starting to pick up some of the oxygen. Some of the oxygen in this area is starting to come through. Some of the reflection nebula is starting to come through. It's reflecting some of the whitish blue starlight of this super bright star that's blazing through. Oh, I should start my musica. Spongy, huh? Everybody's, nebulae is like clouds. Everybody sees something different. Everybody sees a different shape or different something going on. Sorry, Michael. Yeah, my vague Starlink internet connection is kind of in and out. So, yeah, you probably are going to get some buffering. It does that every now and again, but you know, it comes back eventually. So, I'm still here, but yeah, the audio. Sometimes the video will hourglass and the audio will get a little squinky, but yeah, it should come back momentarily when that happens. And we'll do a couple more minutes on this and then we'll move on to the next thing. My monitor, the computer I'm using to monitor, I had to refresh the broadcast, and now it seems to be moving again. So, if the video looks frozen, just hit refresh or F5 and refresh the screen, and it should come back. It brought mine back. Hopefully, it'll bring you guys back as well. I'm not sure. Somehow my computer getting jerked around here must have caused something to the broadcast. Well, it was frozen here for me too, Mike, for some reason, but now it seems to be back. Alright, so let's see now. Kind of getting along on that one. Let's see what we're going to do next. Flaming Star. Yeah, actually, yeah, we can go to that one. So I have my neighbor is here with a friend, and so he's made a request to see Horsehead. So we'll go to the Alnitak region and do Horsehead next. Per special request. If you don't do what he asks, he gets kind of fussy. So we'll just go over there. Yeah. All right. So. That should work. Oh, well, it's totally going to be worth it. Alright, center on the object. That was the Flaming Star Nebula that we were just on, yes. Alright. So now we'll start the stacking again. So it's going to start off and take its first 60-second exposure. And you can watch the progress of each sub-exposure. Right here, this is the progress bar for each sub-exposure. This little yellow bar. It'll go all the way over to the edge, and then when it gets to the end, it'll go out because the first sub is in. Then it'll put it on the screen and take the next one, and then put it out and stack that on the screen and take the next one, and just keep stacking them and stacking them and stacking them. And the more images you take, the better. It reduces the noise, increases the contrast. Brighter areas get brighter, darker areas get darker, etc. Just cleans up. Yeah, it's yeah. Stretch off a little bit. This, because this is being done through a filter, this is more reddish than normal. When I do this with no filter, which on no moon nights I normally do, this is more of like a light yellow or a tan. This is the Flame Nebula here. And this is an emission nebula. This red mat behind here is an emission nebula, which means probably Alnitak is probably making both of these red emission areas light up. And an emission nebula means the bright Alnitak is emitting ultraviolet radiation that is actually irradiating the hydrogen, in this case, in these nebulae, this gas, and causing it to ionize and emit its own light. And so that there's called emission nebulae. And then on top of it is another kind of nebula called a dark nebula, and that is just a spot of dust and dark gas and whatever that's inert or non-reflective or absorbs light, and so it blocks the light of whatever is behind it. And in this case, it happens to be in the shape of a little horse's head. So it's called the Horsehead Nebula. The third kind of nebulosity is called reflection nebula, and that's this little guy right down here. That is simply reflecting the light of the star that's in it. And so it's not emitting its own light. If the star goes out, this would go out. The rest of the nebulosity would go out immediately as well. If Alnitak suddenly went out, these would continue glowing for a while until the radiation eventually died down. But they will emit their own light for a short period of time, at least. Probably 1 million years or whatever. But yeah, so that's another neat thing about this area, is it has all three kinds of nebula in one spot. And like I said, broadband, when you're doing this with just no filter, this is nice and yellow, tan, and the blue and the red, and it just looks. It's a really neat looking area. It's pretty nice this way too, but it's pretty nice area. And so where it is, Alnitak. Okay, so you see Orion. It's behind me. In his belt. 3 stars in the belt. The left-hand star is Alnitak. So that left-hand star is that bright star right here in this image. And so this is the stuff that's right around that star. And the whole Orion region is rich with nebulosity and lots of gas and dust that's forming stars. I mean, it's a huge stellar nursery. You know, the star that we were looking at when we saw the flaming star, that was born there, and it's just kind of shooting across the sky afterwards. And so stars are born there, and then they kind of move out on their own. And so this is just another one of the areas of its nebulosity that happens to be pretty nice to look at. So, yep. No, not at all. In fact, everything is moving. You know, everything we see up there is moving. It's all dynamic. There's nothing sitting still. Not us, not them, nothing. But everything up there is so far away, and there's so much distance between everything that it takes, you know, thousands of years for any noticeable change to occur, like in the constellations or anything. You know, maybe 10,000 years ago, you could look up and things would be different. You know, 5 to 10,000 years, you know, things would look a bit different. But in our lifetime, it's imperceptible in a human lifetime how little it moves, because it's just so far away. But everything is moving crazy fast. You know, tens and hundreds of thousands of kilometers a second. You know, it's just really crazy fast. But there's so much distance between everything that, you know, it's even when galaxies, like two galaxies, will collide. And you'll see them and they'll pull each other all apart and stuff. Even when two galaxies that are, you know, composed of tens if not hundreds of billions of stars each, when they collide, it's extremely rare for anything to actually hit each other, because there's so much distance between all the stars in all the, you know, in everything. And so they get torn apart simply because, let's see if we can get rid of that satellite trail. They get torn apart simply because their gravity wells, you know, impact each other and tear everything apart. Nope. Do any stars go faster than the speed of light? Not that I'm aware of. According to our theory, nothing can go faster than the speed of light. So it's, as far as we know, that's the speed limit. But, you know, that's just what we know right now. Ask again in 10 minutes and it could be something different. But yes, that is our speed limit. And yeah, as far as we know, nothing goes faster than that. Until we can go warp 1, of course, and then, you know, that's a totally different thing. Is he? Good, yeah, he is. Old Will is still going. Not surprising to hear that. Meanwhile, we've lost most of the other ones. Okay, so I think I probably adjust this a little bit more, tweak it so it's bring that in. Well, and the more you know things you stack, the more this will fill, the more the upper part here will fill. I shouldn't point because they can't see what I'm pointing at, but this stuff up here will fill in. Body of what? There is no body of the horse. It's just a little head. That's it. Just that little horse's head right there, like a little rook, like a little chess piece. Not a rook, a knight. No, this is the Flame Nebula. Yeah, see how it looks kind of like flame? That's the Flame Nebula. Do we have to start over now? Normally when I'm not using this filter, this is a totally different color. So yeah, there's a little horsey. Just an area of dark gas and dust. Yep. Seahorse? Yes. Yeah. Hey Ollie, good evening to you. Nice to see you a couple of weeks ago. Ollie came out to the Dark Sky Festival at Furnace Creek a couple of weeks ago and said hi, and we chatted for a few minutes. And somebody wants food. Ink. A little horsey. This would be more of a yellowish tan. This one here would be yellowish tan. This would be the same. This is a definitely full on hydrogen. This has more, probably has more oxygen in it, which is why it's a lot lighter in color. It's a whiter tannish color, lighter tannish color. The filter, the narrowband filter, turns it reddish. But they're both emission nebulae, but it's just their chemistries are a little bit different. This has probably some more oxygen in it, which makes it a lot lighter in color than this one that's pure, almost pure hydrogen. All right. No, that's not what I was looking for. Let's see. What we got? Well, we could do. Yeah, let's do the jellyfish. Jellyfish is always a good one. Yeah, well, a sailor like you should have it. You'll be able to get jellyfish. Now, what I want to do though is I want to get a little bit higher than this because I want to get. There's a cool little reflection nebula star in there. Let's see if we can get that. Okay. All right. So we'll say goodbye to Flame and Horsey Head. And go to the next one. So I just basically push a key combination here and nothing happens. Oh, there we go. And so the planetarium I can click on in here and then click to send it. The planetarium can actually control the scope. So I can just choose what object I want to and then it'll go to it. Okay, and then we'll plate solve, which makes the camera take a quick picture to make sure I'm exactly where I've said I want to be, and if not, it moves it. So you just heard it moved it a tiny bit because it was slightly off. And then because now we're right on where we want to be. It goes out and takes a quick picture. It doesn't actually show you what the picture is. It knows where, because based on where I clicked in the planetarium, it knows exactly where I want to be. It looked at that picture, it just took it and says, okay, you're off by this much, move this much, and it automatically moves that much in the right direction, and so you're dead on where you want to be, which is called plate solving. I have been doing astronomy since my parents bought me my first rickety Sears refractor back when I was about 12. Yeah, it was a great white steel tube and had a few eyepieces and rickety, spindly little legs, and everything jiggled when you looked through it. And it was oh yeah, and I was hooked. It was good enough. I mean, I could see close-ups of the moon, and I could see the planets, and so yeah, it was. That's where it started for me. Well, yeah, the imaging, that's been more like 7-8 years that I've been doing that. Yeah, I started off with a very simple little camera. Not liking how streaked those stars are. What are you doing? Yeah, the deck is way out. Jellyfish. All right, let's see. There we go. The deck finally came back. Yeah, that's pretty good. Okay. So yeah. This is the jellyfish, which we're going to see up here. The head of it's here. And it's all being lit up by this little star here. And so it's kind of faint, but we'll give it, that's why we take more than one sub-exposure, because it'll get better as time goes on. But, yeah. And there's a nice little blue reflection nebula down here. And a yellowish reddish star Propus is up here, and we've got the red of the nebula itself here. The star, this yellowish, this kind of ruddy yellow orange star up here. Yeah. Oh, the name Propus, I don't know. I mean, that's a ancient name, so. Okay. Let's darken this down a little bit. Brighten this up a little bit. Yeah, it kind of extends all the way down through here. Almost looks like tendrils once we get it resolved. That's a good question. Let's find out. It's actually a supernova remnant. IC443. So this was actually a supernova that exploded and blew its gas all around it, and so this is the remains of basically one star did all this. A galactic supernova remnant. It's roughly 5,000 light years away. The supernova occurred 30 to 35,000 years ago. It's a blink in galactic time. He created the neutron star, blah blah blah, the crap. Yeah. It's one of the best studied cases of supernova remnants interacting with surrounding molecular clouds. It's about 70 light years across. You did. You just broke it all. You can't let you near anything. You can't let you near anything. So, yeah, this is like the Hubble, and it's taking more, much longer. So, full image. Yes. I'll be retirement age, and you guys will be pushing up daisies by the time it looks like this. But I'm much, much younger. Yep, so now we just wait. Yeah, this is, this is kind of right, yeah, it's kind of right in the Milky Way. The Milky Way sort of goes right through here. So if we look at it on the Planetarium, so the jellyfish, the jellyfish in it, so it's like kind of right through here. So we're very much in it, which is another reason why, wrong thing, which is another reason why the filter really helps. Because, yes, Jim, you're great. I'll give you a gold star later. There's so many stars in here that the filter's blocking out like 98% of the light spectrum. And so what that does is it only allows hydrogen and oxygen 3 through the filter, which is what nebulae are mostly comprised of. And it knocks everything else back by 98%. So these stars here, if we were to look at this without the filter, would be absolutely, they'd be drowning it out. So it makes all the stars that are there much smaller. It makes the biggest stars smaller, and it makes the smallest stars disappear. And so this is, no, it physically has to be removed. They make things called filter drawers where you can sort of slide them out and slide them in, but no, I don't have that, because I don't usually change filters or mess with it during a session. So you literally screw it you literally screw it under the scope, and in fact, you guys, because you're here, I'll just take this one. Yeah, see, so it's just this is the UV-IR filter. Yeah, it's just, these are 48 millimeter instead of, whatever size you would use for photography. But yeah, so it just screws into a spot in the front of the scope, between the camera and the scope, and gives you cuts out the light spectrum that you don't want. Yeah, some of them are. Some of them are only for like $50. Some of them are hundreds of dollars. Everything that I'm using. Nah, maybe 4 to 5. I mean, the mount, the AM5, the red mount that, it's all riding on. Yeah, well, the bricks, yes. The bricks were there. Yes. And I didn't already have those on the property, so yeah, they cost a fortune. That cost $2,000. The mount. Yeah, the mount. Yep. And so that was the most expensive piece of the thing, and that $2,000. It was, but that's the way it's supposed to be. You should spend the most money on your mount, because it's kind of the most important thing. You've got to be able to drive things precisely, or it doesn't matter what else you got riding on it, or how good a camera you've got. If it's not a precision object, it's not going to work. So that was $2,000. But the rest of it, I buy used. I go online, and there's the forum I use called Cloudy Nights, which is where a lot of these guys that we're chatting with here come from, or know about me from. They have a classified section, and so I buy everything else used. And so the scope was, $500 or $600, and the filters are, a couple hundred depending on what you're buying, and this, that, and the other thing. Well, that's just all skill. What was that? That was your phone. Yep. It made a loud bang. No, so it doesn't take a fortune to do this stuff. It really doesn't, if you know what to buy. And now they're making these boxes. Basically, they're called sea stars or dwarfs. Like 2 or 3 different companies make them, and it's just this box on a little tripod. And you set it on the ground, and you turn it on, and you control it all from an app on your phone. And it's got a camera, and it automatically moves itself. It orients itself to the sky, so it knows where it is and where everything is, and you just point it and send it to stuff, and it just starts taking pictures and sending them to your phone. It's like just these. No, you're not going to get this quality, but I'll tell you, it's not too bad. So if you look at this nebula, $500 or $600. Yep. So usually they're much smaller scopes, so they're going to do a broader, a larger field of view. They're going to be fairly large field of view, so you'll get this and maybe a couple other things in there. So you won't be able to see in any kind of detail. You won't be able to zoom in as much as I can and not have it like pixelate and fall apart, because it's just not, they're much smaller lenses and cameras. But it's push button easy. You put it on the ground and hit go, and the thing just does all of it. Does all the complicated stuff. I've got guiding running here, so this is actually my scope being tracked across the sky very precisely, and these are all the corrections it's making to keep it very precisely on the target. So it's multiple pieces of software, and that's why there's two scopes on there. See, there's the big scope, and then there's a little scope on the top. That's called the guide scope. So it is actually creating the image. It's actually, see, these stars it actually has an image of the stars of what it's looking at, and these circled, yeah, you can use a spotting scope, and these stars that are circled are the ones it's tracking. And so it tracks all of those and makes minute corrections to keep all those exactly in the center, so that the object you're imaging stays exactly in the center, and your stars stay round, they don't get streaky and stuff. So, there's a lot of pieces and parts to doing it yourself, but one of these boxes just kind of does everything. It's becoming push button to do this stuff. And no, it's not going to get images quite this good, but it's easy, and it's very affordable. So, how long have I had this scope? Couple of years, maybe less. Yeah, it's been maybe it's only been a year, I don't know. It's an 8-inch or 200 millimeters aperture, and you can use it at all different focal lengths depending on how you've got it set up. Right now I'm using it at a very fast, very short 390 millimeters of focal length. So it takes more of a wide field image, but it collects light very fast, so it's great for imaging. And then I can change it and put a different reducer on it, so that's 1200, or it's 800 millimeters of focal length, or 1200, or at native with no reducer, no reduction at all, it's 2000 millimeters of focal length, or f10. And that's good for doing close walking on the moon and some planetary stuff. Some of the bigger planets. But yeah, as one of the things I like about this type of scope, it's a jack of all trades, a master of none. It's kind of the Swiss Army knife of telescopes, because you can put different reducers on it and make it do all kinds of different things, whereas most telescopes do 1 or 2 things really well, and that's all that they can do. this Schmidt-Cassegrain scope is kind of the Swiss Army knife. You can modify it with different reducers to make it do all kinds of different stuff. But fast and wide field for imaging is my favorite, because you can get stuff like this. Now I need to adjust this one more time. We'll get a couple more subs on this. I'm basically darkening the background. I'm optimizing the histogram stretch, which is basically making it the background dark and the object a little bit brighter. So trying to increase contrast. So you can see down here, we got a little bit of blue reflection nebula, which does not show up very well because of this filter. Reflection nebula, like I said, reflects the light of the star. And like I also told you, we're blocking 98% of the light spectrum. So reflection nebula does not show up very well with narrowband filters. But nebulas do. You can even see here we're getting some white frosting, white and bluish frosting on here. So that's oxygen on top of the... and probably a little bit of reflection nebula as well from the star that's illuminating this. And then the red hydrogen is coming through there. So is Earth in part of a nebula? Not that I'm aware of. I don't think so. It's just a big collection of gas. No, not really. As near as we can tell. You know, I mean, these like, you know, this nebula, what did we say? It's 70 light years across, or was that flaming star we looked at it? And we said it was 70. No, I think it was this one. Yeah, this one's 70 light years across, which is, a light year is hundreds of times bigger than the entire size of our solar system. So, if we were in the middle of it, and I'm not sure we would even see it. Yes, the monitor that's monitoring the broadcast is about 45 seconds behind what I'm doing here. So this is what we just did when we were looking at the reflection nebula and looking at, see, now it's going to go in when I was talking about that. So yeah, that's always about a minute behind what I'm doing here because of the broadcast lag. So yeah, but I have to monitor what I'm doing because the broadcast algorithms do change. They do change what I'm seeing here on my control computer. It tends to generally darken it. And you can see it's kind of darker on the broadcast than it is on my... Yep. Yep. See, it's all coming out now. Probably hydrogen. Yeah, the simplest. It's the building block of everything. Don't know. I'm not a chemist, so I don't really know. I don't really know that one. Well, let's see what else we're going to look at next here. Look at the jellyfish. No, then go. We're going to do monkey head. Monkey head is next. We're going to go to that one right now. Monkey head. You can relate. All right. Monkey head. Just right next door. We'll send it over there real quick. All right. We're not even going to plate solve. That's such a short slew that I'm sure we're on it more than well enough. Bring on the chimp. Well, it's been cold. The last few days have been cold. Oh no, we've been down close to freezing the last 3 nights. In fact, I had frost on the car on what night was it? Friday morning and yesterday morning. There was frost on the cars. Not this morning. But it's supposed to be 85 by Thursday. So if you can hold out a couple days. Good night, Michael. Thanks for showing up. I'll see you next time. There's the monkey head. This one is obviously an emission nebula again, because it's all red and glowy, but there's a lot of white oxygen in it too. So it's kind of an interesting mix of the two. Oh, hi, Tiffany. Yeah, you're welcome. Thanks for being here. Yeah, so we'll let this build for a bit. Hey, Tiffany, I don't remember if I don't know if I had my mic muted when I said hi to you a couple minutes ago, but if I did have it muted, hello and thank you for being here. I appreciate you here. And good day, Mardacrum. 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 So we're obviously looking at the monkey head here. And Yawa. Why is your name Mardacrum? Anyway, hi Mark. In Yawa. You getting heavy rain there? Wow. So I guess your humidity, but is it dropped below 30 degrees, or is it lots of rain and heat too? What was I just going to do? I was going to look at, let's see, what is NGC 2175. Let's see what we can see about NGC 2175. There's a monkey head. It's an open cluster and embedded in a diffusion nebula. It was discovered by Giovanni Battista Hodierna around 1654, and then independently discovered by Christian Bruns in 1857. It's about 6,300 light years away, so a bit further than what we've been looking at up to now. So there's basically two identifiers for this: the nebula itself and the little star cluster that's in it. It's actually illuminating it. It has different catalog numbers. Anyway, so yeah, it's about 6,300 light years away. It's just back then, it's in the 17th century. I don't think anybody was using reflecting telescopes, so I think they were all simple lens refractors. You know, that's optics was a pretty not very well developed back then, so. Yeah, I guess so. Yeah. Well, and they, you know, when you've been observing, you get your eyes get better, your brain gets better at seeing things. So, as a trained observer, you know, experienced professional astronomers they could see a lot. They can't see anywhere near as much as we can see, but they could see a lot. So, and plus that their skies were a lot darker. They didn't have nearly as much light pollution. Now out here we're a little spoiled because, you know, out here in the desert it's... Yeah, oh yes. Yeah, well that's why I'm using the filter, actually, because the filter, that's when I use the filter is during the moonlight, because the moonlight, it knocks down the moonlight, so it makes astronomy possible, at least in the first quarter of the moon. Once it hits the first half and gets to be a gibbous moon, so bigger than half, then I don't even bother to come out. Actually, that's not true. I have a big Canon camera lens that I put an astro camera on that I use a really restrictive filter on. It's like much more restrictive even than this, and I'll come out and do wide field stuff with that, even when the moon is out pretty well, because it knocks down 99.8% of the light that's coming into it, including all the moonlight. So, yeah. But you know, back then, you know, everything was dark. You know, there weren't no electric lights, and so it was light pollution. Light pollution was turn that fire down, you know, or whatever. But it wasn't an issue. So they had much darker skies and much less, you know, pollution in the air. So probably even clearer. And yeah. So they could see a surprising amount, but you know, we're spoiled. These long exposure photographs through electronic digital cameras, digital sensors is, you know, we'll go to something and, you know, it was named this particular name, and then you look at it and you're like, it doesn't look anything like that, because we see so much more of it than they could have seen back when it was named. So, but visual observers even today will see, you know, more like what they saw back then. You know, our mass-produced $500 telescopes can see more than their priceless optics back then, which were, you know, all hand ground and, you know, making all the optics the way they made them then. They didn't have machines. It was all hand done. Yeah, so Mark says it is in the mid-30s there. So 100% humidity and mid-30s C, which means low 90s. This is Yawa, Australia, North Queensland, I believe. He's about 1,000 kilometers inland from Brisbane, which is on the east coast. He's got Bortle 1 skies, which means very dark. But the reason it's Bortle 1 is because nobody wants to live there. Except Mark. But he's got some great skies for astronomy. And he, in fact, has a C-Star, one of those little boxes that I was talking about earlier that, you know, you push a button and it does everything for you and sends images to your phone. You get some really good images with it. So he's an experienced astrophotographer with gear that's far better than mine. But yeah, he gets a lot out of that little C-Star. And although not right now, because they they introduced a new piece of firmware, basically updated its internal software right before leaving for Chinese New Year for 2 weeks, and it seems to have broken everybody's C-Stars. They can't stack. They get like their first sub exposure and it won't stack anymore because the firmware seems to be bugged. So Mark and thousands of other C-Star owners are pretty pissed off right now. I laugh, but it's not funny. Okay, so there's the monkey head. Let's see, what else can we get to keep Jim here? Uh-oh. We're gonna lose him finally? Oh, well. Are you sure? Oh, I don't know. I could do. You're welcome. You're welcome. Okay. All right. Let's do Lowers Nebula next. This is a more modest nebula, but it's a nice one. Named after Charles and Howard Lower, who discovered it in 1939. Let's make sure I'm on it first. It's a nice little emission nebula. Make sure we're dead on. Right. And then we'll get started on this one. Alright, let that go. Let that go for a few minutes and see what we get. Alright, Lowers Nebula. Let's see what we can find about Lowers. What's the is there an NGC on this? Is there an NGC on you? No, not you, not you. Yeah, you won't let me click on anything now. Click. I love that about Stellarium. You click right on the object and it won't let you select it. Alright. Let's just see if it has an entry under its familiar name. No, it does not. Oh yeah, in fact, I was looking at this the other night. That's right. I found that information about Howard and Charles, the naming of it and the discovery of it. Found that on a completely different website because Wikipedia doesn't seem to have anything. Doesn't seem to have anything on it. But it's another emission nebula, and there is some oxygen and reflection in there too. As we build a few more subs, you'll see there'll be some whitish parts that will show up. And this nebula is located in the upper arm of Orion. So there is Orion there, and his raised arm up here. And so it's right in, Lowers is right at his kind of almost an elbow almost. Right in there. Just noticing we got a little haze around the moon tonight. It's got a little bit of high thin cloud showing up every here and there now and again, but it's pretty sparse. But yeah, so some of our images may get a little fuzzy, but usually it's pretty clear and calm. Pretty nice night. what kind of snake you have. It's not one of your nasty varieties, is it? Sorry about that, Mike. I don't think I had my microphone. My mic was out of alignment, so sorry about that. Hopefully, I sound better now. Thanks for the thumbs up, everybody. Appreciate that. Appreciate the YouTube love there. Yeah, hopefully, Mike, my audio is now better. My microphone kind of slipped down a bit. I got to keep it fairly close to my mouth, or it doesn't hear me very well, unless I turn the gain up a whole lot, and then it's hearing a whole lot of stuff it shouldn't hear, like fabric rubbing against like my sleeves and stuff, and it's just picking up all kinds of stray noise. So I got to keep it down low, but that means I have to keep it near my mouth. All right, let's see. I think that's coming out pretty well. Lowers nebula. A little bit that way. A brown or taipan. A little one, huh? How come they like you so much? Good, thanks, Mike. Thanks for letting me know. Thank you for the feedback. Anytime there's my audio is hinky, please let me know. Because otherwise, I don't know unless you guys tell me. Because I can't listen to my own audio, or I'm getting a nasty feedback loop. Alright, this is a faint enough one that I think I'll go the full 15 minutes on this one to get the most out of it. And then we'll figure out what we'll do next. Okay, let's see. What are we gonna do next? We done at the monkey head. What we got here? Rosette is always good. Rosette is always good. Oh, the Christmas tree is also really good. Oh boy, that's a tough one. I think we'll do the Rosette first, and then we'll go back and hit the Christmas tree. They're both really good ones. Okay, make sure we're lined up. Come on, and we'll get it started. All right, here comes the Rosette. Well, that didn't get very well centered now, did it? I guess I didn't look at my image. Oh, jeez. What the heck? That's where you're supposed to be. Alright. Do this over again. There we go. Now the cluster's in the middle. That should work a lot better. Yeah, I love the rosette too. So we're going to get it better centered so we can actually see all of it, which will be kind of helpful. And then we'll go back and we'll do the Christmas tree. The Christmas tree is also really good. That's a lot better. Alright, got the colors balanced. That there. Back this off a little bit. We're not so totally blown out. It's going to be better. All right, NGC 2244. This cluster has several O-type stars, which are super hot stars that generate large amounts of radiation and stellar wind. The age of this cluster has been estimated to be less than 5 million years, so very young in stellar lifetimes. The two brightest members of the cluster are HD 46223, which is 400,000 times brighter than the Sun, and approximately 50 times more massive. And HD 46150, which has a luminosity of 450,000 times than that of our Sun, and is up to 60 times more massive. But it may actually be a double star. Wow. 50 and 60 times more massive, and 400 to 450,000 times brighter than our Sun. 450,000 times more bright. That's just inconceivable. So these are just new, young, hot stars that were formed in the Orion region, which is just a huge area of star formation, as we have talked about before. So it's just wow. 50 to 60 times the sun. I mean, that would be like maybe the size of the orbit of Mercury or something. I mean, just massive. Probably more than that. And hundreds of thousands of times brighter. Guess it's no wonder it's lighting this whole region up, all these stars. Those are just the two brightest of the ones in this cluster. So the stars in this cluster are doing all that radiating. Hundreds of thousands of times brighter than the sun. And many times more massive. They're just lighting this whole thing up. Probably blowing out this whole pocket of the gas and dust with their stellar wind. Awesome. Now I should probably put in here the object that I'm doing while I'm doing it. Could probably do it smaller than that. Let me work on that. There. That's too obnoxious. Try it there. That's better. All right, let's see. I think that's about. That's coming along pretty well. Let's see about the Christmas tree next. Let's go drop down even a little bit more. Catch the cone and a little bit extra out there. Cool. All right. Cool, that's the rosette. Pretty nice. Christmas tree is a real interesting area. Interesting mix of emission and reflection in dark nebula. All right. Make sure we're there. settled. We'll do this. And start taking our first This one's going to be a fainter one, so we're going to have to wait a little on this one. But it's worth the wait. So this is another area where all three types of nebulosity are present. We've got the red and even some of the white emission nebula. It's all in through here. And some of the really bright reflection nebula that's around some of these brighter stars that you can kind of see in here. It's got these sort of swirly cloud textures on them. And then, of course, the dark nebula that makes up the Cone Nebula. This is the cone called the Cone Nebula here. And this whole thing is the Christmas tree. Sort of like the top of a Christmas tree right in here. All decorated and whatnot. So all three kinds of nebulosity are in there, showing up. It's just a pretty area. It's faint. It takes some time for it to really stand out, but it's worth the time. Mark requesting the Angel Nebula. How unusual. Yeah, that one's really faint. I would have to go to at least 3-minute subs, if not 5-minute subs, to get any sort of respectable image of it. Yeah, it just takes too long. I'm not going to be going a whole lot longer anyway. I'm going to get in and get something to eat because I'm getting kind of hungry. But I think I'm going to do one more thing. Is that nothing? Boy, what do I want to do? I could, of course, do the Orion Nebula. But everybody does that. That's better done in reflection anyway. And I did the rosette, I did lowers, jellyfish, all that stuff. I did the dolphin head the other night, which again is like the angel, is very, very faint, takes a significant amount of time. I suppose I could do the seagull. I haven't done the seagull in a long time. What's this guy? Oh, you know what? Actually, I know what I want to do. None of the above. I want to do Thor. Where's Thor? Yeah. Okay, he was right behind. Yeah, we're going to do Thor. Thor is going to be my last object of the night. Thor's helmet. Then we'll call it a night. I'm not going to bother doing the Orion Nebula and Running Man because those are much better done without the nebula filter in. All right, there's 15 minutes on the Christmas tree. Let's go take a peek at Thor's helmet. I'll call it a night. I haven't done Thor yet this season, I don't think. I've done him yet this season. Plate solve that. Get him in the middle. 78. 78, is that your age you're talking about there? Or are you talking about Casper? Let's get Mr. Thor going here. That we're going to need to do this. First sub. There he is. That came out pretty good for the first sub. It's actually pretty good. That's actually pretty good. I think we'll just leave it right as is. See how we do with a few of these. like that first sub. My guiding wasn't very good on it. Anyway, that'll work. Let that go for a bit. Well, as I look at the pretty crescent moon that's still up in the sky, I'm seeing a whole broad band of clouds moving in here from the west, so this definitely will be the last object. We should be able to get a good amount of time on this, maybe at least 10 minutes or so before it gets here, but yeah, this will definitely be the end of the night because got a bunch of high thin cloud moving in. So, but you know, feeling kind of blessed because it wasn't supposed to have this. Tonight was just not even supposed to be a possibility as of the forecast a few days ago. So, delighted we got some time in tonight. Got a number of good objects, so that's very cool. But yeah, Thor's will definitely be the last one for the night. I had to read your post a few times to figure out what you were talking about. You can cross about, okay, so about 40 centimeters of water, but no more because you've got a battery up under the back of the truck. Yeah. Well, you think you're going to get that much rain? That you're going to get some washes that are more than that? Is the rain supposed to continue all that much? It's getting half fuzzed out now by the approaching cloud front. So I think I'm going to be able to get my 10 minutes on this, and that'll be about it. The clouds are moving in. So far, Canis Major is staying mostly clear, but it's moving in pretty fast. Get another minute or two here, and that'll be about it. Yeah, always crossing flooded roads. Yeah, ours do the same thing here. If we get, they keep the culverts as clear as they can, but it doesn't take more than a couple of feet of water in a wash before it starts thinking about heading over the top of the road, and then you're having to wonder how deep that is. Yeah, the desert is full of washes and crossings and whatnot, so I can relate. Of course, 40 centimeters of water, that's quite a lot of water, especially if it's moving. You shouldn't be driving through that anyway, because that can sweep you right away. So hopefully you'll get out okay. Weather with it, which is nice. I know, Mark, you don't want to hear that, but yeah, it's supposed to be, well, by Thursday they're saying it's supposed to be getting up close to 30 C, which will be pretty darn, which out here is pretty darn nice. Humidity should be fairly low. So that should be pretty cool weather by the end of the week. It's been chilly here last couple days. weather's getting nice now. Spring is moving in. Right here, there are markers of 1 meter and 2 meter in places. Yeah, almost all of our formalized crossings, almost all of our crossings where there's a culvert, we have signs right next to them that are built right on the culvert. So signs stuck into them basically that measure 1 to up to 5 feet. So basically, it's kind of the same thing you got with 2 meters. Ours only go up to about 5 feet, but it's the same deal. So you can tell how deep the water is. But honestly, if it's any much more than 6 inches or so and moving, unless you have a really heavy vehicle, it can sweep you away. It does not take much at all. I know you're going to be fairly loaded with all your stuff, but still, doesn't take much to sweep one away. I think the clouds are already pretty much over it. So we'll take this one last sub and call it a night. Yeah, the guiding is going a little bit wonky because I think it's having trouble. Let's see what the guide camera is showing here. Yeah, see, it's a little fuzzy. Things are getting a little fuzzy. The guiding is going a little bit wonky. Not bad.